Hi, thank you very much. I am Claudio. My last name is Caracciolo, or in Italian it's Caracciolo. It's very easy. Yeah, it's very easy. Okay, I am very happy to be here. It's my first time in Paris, so thanks for the committee for accepting our talk. It's with me, Sheila. Say hello, Sheila, to all people.
It's my second time here, and thanks for coming.
Okay, our talk is about car hacking, but before the start our talk, we have to introduce ourselves. So who we are? We are researchers. We work for Telefónica, for a company from Spain. We work in a special unit that is the cybersecurity unit of Telefónica. And both are from Argentina. Do you know about Argentina? Just Fernando told you. and when we start working or talking about car hacking, the people always ask when we start with this project, with this specific project. And the answer is 2 years.
Yeah.
It's 2 years. But the first conference when we present this project, not this talk, this project was in the Eco Party in 2007.
Yeah.
60s. Wow.
16.
Sorry. And at that moment, the talk was like different because we have to introduce a lot of car hacking and a lot of concept of car hacking. And we start talking about this because both love security and both love cars. So this, we share the same passion for these topics and just start researching in different moments. I start in security 20 years ago.
You're old, huh?
Yeah, she has 1 year. Yeah, yeah.
Almost my age. I'm 23. It's the battle all the time.
All right. Yeah, this is a problem. But in a different way, because car hacking is not new, but car hacking from a security point of view is quite new. Yeah. Why we start in this project, or why we start with this type of talk? When we started in that moment in the Eco Party, in the conference, there was a lot of another talks about car hacking, the very good talks and very good researching about car hacking. There was the investigation of Charlie Miller about the ships hacking. And the problem for us is that that type of car, the same that I can see here in Paris, there is not in Buenos Aires. In Buenos Aires, the car is like this one. Yeah. We don't have the same technology, and so we have different problems to control some car remotely. So we decide to continue with the CAN research that some other person do it, but implementing some form of backdoor in this type of car. Because if we try to do with SIM cards or TPM or with GPS or with Bluetooth module or infotainment, that module in Buenos Aires, in the cars of Buenos Aires, is not the same that you implement here. For example, the infotainment here for a Citroën or for a Renault is the same console, but it's different. So you have in Buenos Aires more or less function. Yeah? So we try to do something different. And the most people ask about if you can break your car trying to do something. And this is what can the type of problem that you could be with your car. This is a simple demo. This is one car on Citroën. This is working. You can see here. This is the engine started, and I just connect a sniffer, not this one, a sniffer, yeah. And the car just stop. Yeah? This is a problem because what happened here? In that car, I do a lot of tests injecting packets, and when I try to connect everything in the connector, the engine stop function, yeah? But how can I repair this one? Okay, I need this button, but there is not in the car, so I just release the battery, wait some minutes, connect again, and start from the fall, yeah? It's very important that when you try to do something with your car, if your car is with the engine stopped, you can do everything that you want. But if you try to inject some packet in your car when your car is with the engine started, you have to be careful because you can cause some damage to other people, to other staff, to your house. There is no so important how many trained are you because accidents occur, yeah?
Oh.
Bad. It's really bad. So with this simple starting point, we have to do a quick review about the CAN and how you can use that and what type of information you can find in your car. Everyone knows, or everyone that like cars, like car hacking, knows this port, no? This is the OBD port. Estoy muy mal con mi inglés hoy. Sorry. This is a very common connector in your car from 2006 to today. It's mandatory to every car, and there is very type of connectors, but there are two that represent the CAN bus, or the connection to the CAN bus is this one. Many cars don't have this connector or these pins here, but that doesn't mean that your car doesn't have CAN. Your car has CAN itself because if you access to the ECU, to the computer of your car, you can access to the CAN. Yeah, this is the exposure of the CAN. When you try to repair your car with a specialist, he connects a computer, a normal computer, to your car to get some packets, some information on your car for diagnostic. The connector for doing this is normally these two. Some cars use these two. For example, Audi, yeah, Audi or VW use this other port. But there are different protocols running in your car, in the network of your car, and with different combination of connectors. Yeah.
Okay, this is a little bit difficult and broad part, but it's necessary to understand. So I will try to explain how CAN works. So when we start learning about CAN, the first thing that we will see is the CAN bus. That's why CAN protocol is based on a bus topology. Each node might be a sensor or a vehicle ECU, and the information transmitted on the bus can be used by several nodes at the same time. Since CAN was developed for using in automotive environments where there is a lot of noise, it uses a system known as differential voltage that allows it to gain immunity against interference. In this system, the transmitter transmits a signal in duplicate, one with positive value and the other one with negative value. These are the CAN high and CAN low signals. And if the receiver receives two signals that are not equal, it discards it, assuming that it's noise on the bus. Moreover, CAN has another routine known as inverted logic, where we have a dominant state, which is 0, and a recessive state, which is 1. This influences a little bit on the frames format. That is a standard CAN frame. The green part is the arbitration field that contains the frame's ID. And because of the inverted logic, those IDs with mostly zeros will have the higher priority on the canvas. That's why, for example, the CAM frames related to the engine have the lowest ID. That means the higher priority on the canvas. Yep. After that, in yellow, we have the data length, and in red, the data itself that can contain a maximum of 8 bytes. As we can observe, there are no source, neither destination addresses, nor source or destination ports in the CAM frame like protocols we know better, such as TCP/IP. So a CAM node has to check the arbitration field to know if it should take the frame's data. This is how CAM frames look like. We have the ID, the data length, and the bytes of the frame. It can contain 5 bytes, 4 bytes, or 8 bytes at maximum. An important thing we have to know is that a CAM frame does not indicate anywhere what kind of information is carrying. For example, a CAM frame carrying information about the RPM does not indicate anywhere that its information is about RPM. So to find out what kind of information each frame is carrying on, we have to do a reversing process, a boring reversing process, and spend so many hours in the reversing process. For that reversing process, we have different tools. For example, this one is an oscilloscope, and it's the lower level tool that we can find to analyze CAM signals. In our case, we had a CAM module that allows us to see the hexadecimal representation of such signals. An oscilloscope is useful to analyze signals in general, but not much for doing car hacking itself. The CAM frame are pacing very fast on the screen, so we have to be flash to understand. And we are not flash. So for doing car hacking,
you need a module for this oscilloscope, no? You need a module.
Yeah, we have a module.
Okay.
For doing car hacking itself, it's more useful higher level tools. For example, this one. This one is a canvas analyzer from Microchip. And as we can observe, we can see the CAM frames in a nice way, so we can analyze them more easily. However, we are seeing a lot of CAM frames at the same time, and we don't know what kind of information are on them. So the great question is, how can we find a specific CAM frame? For example, if we are trying to get a CAM frame of the headlights of the engine, what is the process that we have to do to get that specific CAM frame? So the first thing that we have to do is to choose a tool for sniffing the canvas, buy one. For example, nowadays there are several tools to sniff in the canvas. We have CAN Spy, CAN Loop, CAN Analyzer from Microchip, or even we can use Socket CAN together with an open hardware tool or make our own tool as well. So after we choose or buy a CAN Analyzer or CAN Sniffer, we have to start with the reversing process. For example, here we have a CAM frame of a Renault Master pickup, or Renault pickup. And when the headlights are off, we can see this specific CAM frame. And if we turn on the low headlights, we can know that the first byte is changing its value from 40 to 46. And while the low headlights are on, every time the byte is 46. Yeah? If we turn off, it returns back to 40. And if we turn on the high headlights, we can observe that the second byte changes its value to 1E. So we have to spend so many hours inside the car and perform actions, turn on, turn off, turn out, turn off all the time, and observe what bytes are changing this value in any CAM frame. That is the only way that we have nowadays to find out a specific CAM frame. When we began, we started using Canvas Analyzer from Microchip. And usually, these tools allow us to inject in CAM frames on the canvas. But usually, the frequency with which these tools makes that transmission might not be fast enough for the canvas. That's when this happened. Every node in the canvas is sending its current status constantly. In this case, the headlight module is sending that the current light status is off, while we are injecting every 100 milliseconds that they are on. So that's what produced the flicker effect.
If you think about how cans work, you can see that it's like a switch on your house. You turn off the light, and the light is on, and that's all. But in a car, it's different because every message is sending every time. So the device is telling to the echo, the light it's on, the light is on, the light is on every time. So that's what's happened in the video previous. In this example, you can see what's happened with a very simple car. This is a VW Fox with a mechanic switch, and when you start the switch, all these frames change. So you don't see just one frame or one data line changing. You see a lot of frames changing. So it's very difficult to identify one specific changing when you start the light. So, for example, this is a car from 2030. Yeah, but if you try to do this one or try to read the information when you start the engine or put the engine or the key in contact mode, the cars start flashing a lot of instrumental in your car. So you have a lot of message from every single light in your car, and you don't know what's happened, really. If you try to do this one in an Honda Civic, more newer, like this one, all this, there is a lot of frames in your car. It's like seeing the Matrix movie. You can control the message, so it's very difficult to identify. So what we do with all the information when we obtain the specific CAN message that we are searching, we try to backdoor the car. We was trying to identify a specific CAN bus or a CAN message to backdoor in a car, but not with a Bluetooth module or with Wi-Fi module. We want to backdoor in a car and control the car when the car is far for us. Yeah. So we start working in our project, but not based in our RSP, either in our Arduino. We are working in our electronic module. Yeah.
Yeah, when we start with this project, we made a simple CAN frame injector. We use a PIC 18F2685 that's from Microchip that supports CAN, together with a transceiver for converting the CAN high and CAN low signals. We developed the firmware in assembly so it's work fast, or at least fast enough for the canvas, avoiding that what we saw in the previous video. OK, it's worked fine. But after that, the malicious ideas come in. And we thought, how could we control it remotely? That's when we added a SIM900L module for sending SMS command. So now we have to send an SMS command to the SIM900L module and start to inject a specific CAN frame from any geographical point. And that was our first the Bicho version. It's next to the OBD2 connector.
This one.
Yeah, the blue is the OBD2 connector. And
this is the connector, this is the module.
That was OK, it's awful. It's the first version, 2 years ago as well. But this first version had a little problem. Every time that we want to inject a CAN frame, we had to hard code in the CAN in the firmware. So any stupid error in the 0 or 1, and it wasn't work. And we had to recompile and recompile again and again. So no, it was awful. we thought that it would be nice to set up the cam frames using a USB interface in a desktop software that's more useful for our target. So for that, we start making some changes in the hardware. We added a USB interface, and we added a deep switch. The deep switch allows us to toggle between two modes. We have now the programming mode. The programming mode is when we are connecting the Bicho to the computer, and we are programming the cam frames that we want to inject, and some advanced setup that we will see shortly. This is the programming mode. And the other one is the hacking mode, when we are connecting the Bicho to the OBD2 port of the target card. Yep. So we have the PIC, the transceiver, the USB interface, the SIM-100 module, and the deep switch to toggle between these two modes. That was the improvement that we made for the second version of the Bicho. But of course, this new hardware, with these new changes, we had to improve the firmware as well. Now we have two different subroutines to process the data. For example, we have a subroutine to process the data coming from the computer, and we have another subroutine to process data coming from the SIM-100 module. When we are receiving an SMS, we have to check what says the SMS, and to know what cam frame we have to inject, checking what is the command, and of course, making the cam transmission. Actually, we have 2,150 lines, and really, we don't know who wants to keep on this code.
So if you want to maintain it, yes. Yeah.
No? OK.
All right.
OK, so this was the second version with the USB interface. However, we made another version, really a little days ago. When we made some new improvements, we added a little USB interface, mini USB interface. And we added new features to the firmware as well that we will see shortly. So here we have the evolution, first version, second version, and the third version that is the last one.
So as Sheila said, programming this in assembly is not a good idea for all the people. So we try to do this version some different, and we add the USB connector, and we development a software, yeah, for programming this device. So we create this software in C++, and the main idea about this software is that you don't need to know anything about programming. You just know the front message, the CAN message, that you need to use for your car, and you can identify the ID for controlling a specific device on your car, the lane, the message, and you can specify the SMS control that you want to use in uppercase in 4 letters. Yeah. In this case, we have this version with some special feature. For example, we add a filter, so bad people like you can control my car. Yeah. If you send some message to my car, I can control my car because I just add my phone number. Yeah. And we add another features, like one of them is the kill echo. The kill echo is sending message with all zeros, so the echo will give the more priority to the message and stop attending the other message of your car. Yeah, so the car stops. Yeah. And we are working in another 2 different features. One of them is the possibility of setting up an attacker payload to run automatically when the victim's car is proximal or near to a given GPS location. And the other one is, I'm sorry, this one. And the other one is the same. It's setting up an attacking payload to run automatically when a specific frame is given to the car. Yeah, it's taken to the car. If we try to set how difficult it is to use this, we can do a simple demo. For example, you can download the software.
This software is open source and it's free, so it is on GitHub. You can download it.
Shows you need to connect the device. Okay, this is a virtual, so one to Linux. You have to put the switch to the low connection, yeah, to the and run the program. So yeah, this is how you see the connection, but at this moment, the device is connected, but the software is not function with the hardware. So you have to connect this one. The lights change, setting that is ready to receive information. Yeah, and you just add the information that you want here. I have a file, a template with the information that I need. So I can put this information is faster. Yeah. And I need just to add my phone number.
Hollywood phone number.
Hollywood phone number, yeah. And write. That's all. I have to disconnect this one and change the position of the switch and connect this to the car. And I can, from this moment, I can send this message to turn on the lights, this message to turn on the light from the stop pedal, yeah, or for the pedal gas, yeah. So it's everything configured. Okay. ¿Quiero venir a presentación? So, one more. The problem at this moment is we have the software, we have the hardware, but for everyone, the problem is to know the CAN message for your car. So that is the most important thing for you can configure this one. So we create an open database for recollect canvas. So the idea of this project is that if you are searching message for your car, you can share that message with the other person in other part of the world. So you have to identify the ID, the DLC, the rest of the information. With Vector is for this specific message, with type of car, and for which country is that car, because it's different for every type of car. And if you don't have a specific model, you can add your model. And if you don't have a specific vector, you can add this vector. And we have a method to verify. So if I set a message or I share a message in this web and nobody tests it, you can see that message, you can use that message, but anyone can say that that message is real. Yeah, there is some people that can test and say yes, it's correct. This message is for the light. This message is for the air conditioning or whatever. Yeah. So what is the problem? The problem is normally there is a lot of people that send us mail asking us for some specific model, a specific brand, and when we add that brand, nobody share his message or his research. This is very common. Yeah, okay. We have at this moment three things: the hardware, we have the software, and we have a database with information to use. So what can I do with this one? Just fun. Yeah. So I can play with this one. This is an example with the same car that we tried before. This is a Citroën. Yeah. You can see the light is off. Nobody in the car. Yeah. I send a message to the car. Uppercase. Yeah. And the light start flashing. Yeah. Nobody in the car. Yeah, nobody in the car. And I send another message for the pedal gas. Yeah. So you can see the RPM here. Huh? Thank you. Thank you. The beautiful thing about this is that I can control that car wherever the car is it. Yeah, so I don't need to be near to the car. The problem is when I could backdoor in a car, in what moment can I put this one in the car of the another person? If I want to backdoor in the car of Inti, I need to access to his car. So how is the moment to do this one? For example, when you try to car wash your car. That's good. That's good. Yeah. Or in a valet parking, or you can pay for some spy services, and they can put this one for you. Yeah. It's the importance of social engineering here. No. Is a good moment. So what more with this project? Normally we say that that's all, yeah. But from some months ago, we are working in a different type of vehicles, yeah. With this one, we have trying. We have some problem because I don't have one of these in my house. Yeah. So I can do the research so faster. And when I go to the person that give me these vehicles, I say, can I disassemble this one? He say, no. Okay. All right. In our country, we don't have problem with this one, but in some other place, there are some problems. For example, the people of Johnny Deere don't like that you hack his vehicles, yeah? So his farm. So there is very different legal problems in states. But in Buenos Aires don't have a lot of John Deere, so I mean, it's the same. I have to say thanks to all the people that support us. There are friends from Argentina, and this guy is from San Francisco. He's Argentinian too, but he's from San Francisco. They are supporting sharing information or sharing things and so other stuff. And I have to say to you, good luck tomorrow, but not so much. Not so much, yeah? And thanks to all for stay here and for inviting.
Thank you.
Thank you.
Questions?
Hello. It's nice presentation. So
Thank you.
Here.
Right.
Okay. So have you done any bypassing gateways or other hardware secure module while backdooring stuff?
I'm sorry, I don't understand you. Sorry.
Did you successful in bypassing gateways, rather HSM?
I don't have any car with gateway, so
Okay.
I don't know. Yeah,
Yeah.
I don't
Thank
know.
you. Yeah.
Hi.
Hi.
Question: do you have any idea on how to solve this flickering problem? How can this be solved?
Again, please.
Okay.
The problem with the faster of the model, because the problem, it was not the transmission of the connector. The problem was the software. The microchip software or hardware too, yeah, is transmitting
Every
with
100
a
milliseconds.
frequency the 100. And when we write this program in assembly, we transmit faster than that. Yeah, so we can resolve easily.
Okay, thank you.
If you don't use microchip and you use
Carl.
car loop, yes, this one. Can you please give me the image here? Thank you. If you use this one, oh, sorry. I can find. This one. If you use this one, car loop is an open hardware. The cost is $30. Is cheaper. Yeah. You can use the this connected with your Linux and send information and send done faster like us. Yeah, it's the same. Yeah, you don't have the delay or the limit that have microchips, because the idea of the microchip is not send message, it's read message. Yeah, you send message just to verify something. Yeah.
Yeah, the idea there of microchip is not hack a car. So
Yeah, we send message for malicious
testing.
mode, yeah, but it's not for microchip. Yeah.
Is there multiple OBD ports in a car, or is there only one near the
no, it's just one. OBD2 port is just one. You can have different CAN buses, but in the OBD2 port you have spot one CAN bus. So, but in the car there are more CAN
Yeah,
buses.
in your car you have a lot of ECU for different things. For example, normally the airbag system has a specific ECU, yeah, just for this component. Normally, this depends on the car, yeah. So you, when you connect with this connector with the ODB2 ports, this one, you have access just one of that CAN bus, yeah. So you can connect two old device that is connected to the same CAN bus. In some cars, you have access to almost everything, but normally you have different networks, yeah, and you can control different things. But even if you don't have the ODB2 for the other CAN bus, you can access to the CAN bus. You just to know where is the ECU and search the cables, and you need to medir,
Measure.
to measure, yeah, the power between these two cables, yeah.
Thank you.
Yeah, you're welcome.
Adding to the previous question, so I just wonder if Infiniti Q50 is, is Infiniti Q50 available in Argentina or not? Do you know? No. The reason I'm asking is because it's the first car with steer-by-wire, like publicly available. So its steering wheel is physically not connected to wheels, and only electronically. And the system, which actually electronic system, which actually connects steering wheel to wheels, is told, the manufacturer tells that it's not exposed to CAN bus, but it's interesting whether it's true or not. So
Yeah, there is not a standard for CAN message. So every manufacturer do what he wants to do with this, and there is not one standard for one brand. For example, if you take some BW, like a Fox, is very different to a Jetta or a Passat. Are very different, and you don't know why. So there is not a real a real idea of how to deal with this one. Yeah? There is different projects. There is some project to a new version of CAN, but the reality is that new CAN protocol will be implemented in a few years, because you have to change all the cars. Yeah. So.
get it. Thanks.
Thank you.
Hi. When you reverse engineers message of CAN bus, do you think it's possible to automatize the process? For instance, you go through cycle, you collect all the data, you make a baseline, for instance, of all messages going through the CAN bus, and from that you can identify like suspect for such function.
We use two different methods because she used the microchip that is more visual, but you can collect the information. Yeah? I use Carloop, sorry, it's not my day. I use Carloop and I use Linux, so I can do some programs to recollect all the information and start checking and doing some filter.
Carloop use Socket CAN. No? Carloop is using Socket CAN in Linux. Socket CAN is a little bit faster. So there is another tools, open source hardware, I don't remember now, but there is open hardware tool that you can use together with Socket CAN that are faster than microchip. I bought microchip because, okay,
it was
it's
good
nice,
to understand what happened. Yeah, it's good because you see visually all
it's
the
good
movement.
for starting.
But when you try to research or to reverse information about what happened with your CAN, you need more faster tools. Yeah?
Thank you.
That's all? One more? Sorry for that.
Hey,
one.
because from your software it seemed like you're sending one packet, like one frame per command that you specify. Yeah. But is it possible that you actually, I don't know exactly how it works with CAN, but is it possible that a single action that you want to generate actually requires multiple frames to be sent over the bus?
Sí. Si es posible generar múltiples acciones con el... Yes, it's possible.
Yes. Sometimes there is a byte, a specific byte for an action, and in the same frame, another byte for another action that nothing had to do with the other one.
He's asking about if
but
you
the
can
opposite.
send parallel message, no? Is that the question? Yes, you can. Not with our design, but you can control that. Our design is a POC, it's just for fun. It's not professional thing. So you can use more complex model, more complex electronic to send more message in parallel, like your car. Your car sends a lot of message in parallel. But for us, for this type of concept, we don't need. So we build this solution with just one message for one message at a time.
Thank you.
You're welcome. That's it. Thank you very much.